it was meant that only a few people could watch the video feed. So it was first deployed in 1942 during Second World War when the Germans wanted to just monitor their launch of rockets. So the first CCTV camera itself was developed by Siemens, Germany, 1949. So US-based company launched the first commercial CCTV system only for monitoring, but recording was not possible. The 1968, the first VCR, the video cassette recorder, was invented and opened more opportunities. Then New York was the first city to install CCTV to monitor some important streets. Then 1973, New York Police Department installed CCTV to monitor streets to deter crimes in Times Square. In 1980, the spread of video surveillance across US. 1985, the first CCTV installed in UK at a seaside town, Bournemouth. Then 1987, the first local government surveillance system installed in Kings Lynn, Norfolk. This year saw a huge number of CCTV systems installed in public places. Then 1998, over 3,000 CCTV installed in New York. Private business and organizations started investing heavily in this technology. They started realizing great opportunities, and it also prevented, it was exclusively for safety. And so from that perspective, it started picking up. Then 2001, following the 9/11 attack, okay, it became more prominent and CCTV became mandatory. And so it started spreading across the world, and there was a need for CCTV system to be deployed to ensure safety of the common man and assets. So now what does a video, so now coming to the more technical part of it. So what makes up a video surveillance system? Completely a functional system. So the hardware, it consists of cameras, it consists of recorders, storage, networking, power, central monitoring stations, and software. Okay, like we have software which is called video management software, video analytics, and things like that. So basically, let us look at the heart of the CCTV system, which begins with the cameras. So the camera is the eye of the entire video surveillance system. And what does this camera consist of? It has imaging sensors, it has an optical system, it has the associated electronics, and an enclosure box to protect it from all weather harsh conditions. Then what is this imaging sensors? So these are semiconductor devices which actually produce a current when light falls on it. Basically, we call them as photons. So basically, when photons, light strikes on this semiconductor device, it produces a small current output. And the intensity of the current is proportional to the lumens, that means the light intensity. These devices are called as photodiodes. Many of these photodiodes will be organized in rows and columns, which makes up an array and referred as imaging sensors. So basically, sensors are classified into two categories. Basically, you find CCD is called a charge coupled device. The other is called the complementary metal oxide semiconductor called CMOS. Let us look at both the technology, how it has evolved. So CCD technology, basically, it has the photosensitive elements, okay, which are arranged in rows and columns. And when each pixel receives a certain amount of photons, okay, so converted into electrons. These photo electrons are stored in a charge well. It's called a potential well, which means it's a tiny capacitor, okay, a capacitor which gets charged by the current and it stores a charge. That's why the name came as charge coupled device. That means you have that every pixel, okay, which is a photodiode, pushes its current to charge a capacitor, and this will hold this charge. This charge is actually proportional to the intensity of light or represents the original pixel intensity in terms of lumens. And then these charges are shifted through a serial register, and once they are coming out of it, they have to be amplified because the signals, the charges that are produced by these sensors will have very low, weak signals. So there's an external amplifier which can be amplify the signals, and also if required, they can be converted into a digital form. These are all analog signals. The analog can be converted to digital form. We'll come to it later. While this operation is in progress, okay, the camera has a shutter. That means the shutter is the one that is placed in front of the lens. The shutter opens and allows the light to pass on the sensors. So while the shifting of all the charges are happening, it's an electronic shutter. The shutter opens while this operation is progress. And then there is a clock, an electronic clocking circuit, which shifts all the charges for each row. And the shutter again resumes back to its normal operation. So this is a diagram. So you can see that these are all there are pixels. These colored maroon. These are all the photosensitive elements, and there's a serial shift register. So all these charges gets into serial shift register, and then finally it comes to an amplifier, and where the signals are amplified, and finally it goes to an analog to digital converter. This is basically the architecture of a CCD imaging sensor. And this is a picture. This is an image of how the earlier CCD sensors look like. Then let us look at the other technology called the CMOS. So basically, it contains active pixels, which means that in every photodiode, a photosensitive element, has also got its own built-in amplifier, which means as light falls on the photodiode, okay, it immediately gets amplified and the corresponding output is available. So which means you don't have to do the clocking very frequently, shift it in parallel at one shot. That means if there are, let us say, 100 by 100 photodiodes, for each photodiode, row-wise and column-wise, it's got its own amplifier built into the chip. So it will amplify the signal and make it available. And each pixel can have its own analog to digital converter. And so you find that in case of CMOS, it is something like parallel. As light falls on the sensor, okay, all the pixel information values are available at one shot. It can be taken and processed later. So you can see the picture also of a CMOS sensor. You do not find much external components. So this is basically as compared to the CCD earlier, there was a printed circuit board, there was a sensor, and surrounding the sensor, there are many other external components. But here in CMOS, it is all built into one chip. And here's a diagram. So these blue colored ones are amplifiers. So for every pixel, there's an amplifier. So, and this gets shifted out and it will go to an analog to digital converter. So I am not doing again an amplification externally. The amplifier is built into the chip, and only thing the digital output, okay, that means whatever the chip, the amplifier produces out is just given to the analog digital converter. It could be multiplexed, and then the digital output corresponding to the value of the pixel is made available. This is the architecture of the imaging sensor, which is CMOS based. Then a simple comparison. Basically, CCD sensors create high quality low noise images. But while CMOS sensors are more susceptible, but actually this was earlier, CMOS sensors were more susceptible to noise earlier because the fact the amplifier also was built into the chip. But later on, with advancement technology, this has been suppressed. And because in each photo site in CMOS sensors, it has many transistors. So which are very adjacent to the photosensitive element. So only some of the light falls on the transistor, while the remaining will go on the associated components. So that means the quantum efficiency may not improve. Okay. Whereas the CCD sensors, and that is one part of it. And so this reduces the light sensitivity overall. Okay. So this is one small drawback which was encountered a few years back in the very beginning evolvement of the technology, but eventually this has been overcome. As you know, there's a constant innovation, improvement in technology. This has also been overcome. Power. The most important is power. CCD sensors consume 100 times more power than CMOS. So really not feasible to have them into cameras, because as all manufacturers cameras know, the power consumption is a very important factor when they design the sensor. And so CMOS that way scored better than CCD. Then CMOS sensors can be manufactured easily on standard silicon production line. So today you find that most of the semiconductor devices that we talk about, intelligent chips and system on chip, all the very large scale integration. So you have the manufacturing capability, and the production of these devices becomes very cheaper and also easy. So that is the reason. One of the reasons CMOS became very cheaper to produce, cost effective as compared to CCD. Then CMOS sensors, they tend to have wide dynamic range as compared to CCD. That means the entire colors. If it is a colored, you can see the entire color spectrum covered better than CCD. Then CMOS sensors can be deployed for high-speed video capturing. So when you have operating the sensor at higher frame rate, normally we refer video at 25 frames per second. That is a normal video which you capture so I can perceive the movement. But sometimes the sensors have to have a higher frame rate. For example, if a vehicle keeps moving at 40 kilometers, 60, 80 kilometers for moving vehicle, so the frame rate deployed should be higher. So CMOS can provide this. Then also look at the pixel size. So CMOS technology is very advanced. It can provide you what you call smaller pixel size, which means the distance between each pixel can go up to 6.5 micrometers and with 90% quantum efficiency. So today, the CMOS sensors can boast about higher quantum efficiency and intergap, that means the distance between two photodiodes. That means basically they are called photosite receptors. So the distance start becoming smaller and smaller, which means you can have more pixels row and more pixels column. So let us see how this is going to affect a very important terminology called resolution. So today CMOS has become an accepted technology, and today almost 100% of all surveillance cameras, including your mobile phones, the technology uses CMOS. I'm sorry. Then the size of the sensor. So the size of the sensors can vary by 2 by 3 of an inch, that's 8.8 mm, 6 mm. So that is the size, physical size of the sensor itself. Okay, and this can pack. Okay, the total number of pixels describes the total light receptors. That means within this small area, how many photosensitive elements I can pack, row and column. So larger the size of the sensor, which means I can pack in more photodiodes. So even that means overall sensitivity of the sensor can improve, even the light sensitive, as I increase the number of photosensitive elements. This can happen if I increase the physical size of the sensor. So if the sensor becomes slightly larger in dimension, I can pack more photosensitive elements, and that yields a good quality of the image. Then there's a term called sensitivity. So this is the minimum lux, the light required to produce a clear image without any noise. When I talk about image, we are now referring to everything as color images because we are completely in the color domain. We don't produce any more black and white cameras, they're all color. So typically ranges from 0.1 lux to 0.0001 lux. So zero point 0.1 lux is something which is acceptable, which is something available. But when you look at a lumens as 0.001 lux, which means these are special cameras. Sometimes it is guaranteed to produce, that is even starlight. They're called starlight cameras. That means even in the starlight, night, it can still produce reasonably good color image, but these cameras are very expensive. So that means 0.001 lux, even if that's low light, it will still produce a color image. Then what is resolution? What does the term resolution mean? Basically, in the spatial domain, that means the physical space, it is the smallest distance between two pixels in the sensor itself. So the smaller the distance, okay, between each photoreceptor, better is the resolution. Okay, which means I'm packing more and more photo elements within the small edge. That means I'm having more pixels. Higher the pixels, higher is the resolution, right? So today we have gone up to 1.5 micrometer in the sensor. That means from 7.5, the spacing between two photodiodes has been reduced to 1.5 micrometers. Then these are basically as far as the imaging sensors are concerned. Then let us come to the optics. Now, you all know that this light captured from the object has to be focused on the sensor. So this is the lens. So basically, the lens plays a very crucial role in capturing the image and properly focusing on the sensor area. You can see the sensor will be 2 by 3 of an inch. It's a very tiny sensor, and so the entire image captured should fall on the sensor. And it should produce a vivid, sharp image. So the lenses are of two types. Generally, we have two types of lenses. One is called a fixed lens. The other is called a varifocal. The fixed lens will give you what I call the focal length. Basically, the focal length decides the field of coverage. So if I use a fixed lens, let us say a typical example, 3.6 mm lens, I can have a field of view of 78 degrees. While a 12 mm lens can provide a viewing angle of 30 degrees. They are inversely proportional. That means the focal length and the field of view are inversely proportional parameters. So, but many times it is good in depending on an application, you can choose a camera. If your application does not demand for varying the focal length, you can go for a fixed lens and you can be assured of 78 degrees coverage. But in a place where you think you may want to vary the focal length, you want to vary the field of view. Okay, right from, let us say, a small edge that is 30 degrees up to 78 degrees, you want to have a control on the focal length, then we have to use a lens which are called as varifocal lens. That is one single lens where you can change the varifocal. That means the focal length can be changed. And these are very commonly used in surveillance cameras today. Then the shutter. So shutter is basically a device which allows light for a specific duration of time. So the shutter speed is electronically controlled It can be starting from 1 second, and it go by 1 divided by, okay, 10,000 of a second. So that means what is ultimately going to happen, which means during daylight, enough sunlight is available. So I can keep the shutter duration very small. Okay, so I'm capturing more light. But during night, as the intensity keeps falling down, I have to open the shutter for a longer duration to capture more light. But ultimately, is it going to read in a good image? Well, it can. It is a question of experimentally trying it out. It depends on application. And sometimes in the night, you may find vehicles going at fast, higher speed. So if you keep the shutter quite small, it will be able to capture that. So the shutter speed is completely depending on the light conditions. Okay, and also the frames per second. The number of frames that you want to produce per second is also related to shutter speed. Then iris. Iris is a very small opening. This opening, that means you can make it smaller or wider in diameter, the amount of light. In shutter, we're talking about the duration, whereas in iris, I'm talking about the amount of light that can fall on the sensor. So here, there is an automatic sensor also built into the camera. If the outside light conditions is good enough, large quantity, large intensity of light is available, the iris makes its opening too small, so it allows less light. While outside, if the light intensity goes down below a certain threshold level, the iris will open wider, which means it allows more light to come. So this is also controlled electronically by the sensor. Then optical range. So basically, it is the distance at which all the fine details of the scene's object are captured. It again depends on the type of use and also type of the focal length of the camera used. So if you're looking at a 3.8 mm wide angle lens, okay, the pixels spread apart very quickly. So what happens is that as the distance keeps moving out, because it is a wide angle, 72 degrees, the pixels start spreading out as the subject, that means the person is standing in front of the camera, and he keeps moving away from this distance. Then what happens? The pixels also spreads out. Then what happens? It just could result in a pixelation. Okay. Whereas if a 12 mm lens, what happened? A telephoto kind of lens, it is focused very narrow, and all the pixels are close by. So you find that you can get a better resolution. Okay, even the person walks a little backward, I can still capture him with greater clarity, and it will not result in pixelation because of the 12 mm lens. So you find this optical range, okay, is a function. It depends on your focal length of the lens and also how you want to use it. Then camera electronics. So all said and done, we are producing a video signal. So how to produce a video signal from the data signal produced by sensors? So these are basically, I'll not go into the television details, how something called as raster scanning system. So there is an electronic scanning system which scans line by line, and then there's something called as, we call it as a frame. So we talk about 25 frames per second, and each frame will consist of two fields. One is called the odd field and the even field. That means the electronics will scan the, or let us say, this even field first, then it will scan the odd field first. It pushes out all the data, and then we put them together, it becomes one frame. So a frame consists of an odd field and an even field, and such like that we'll have 25 frames per second. Okay, so this is all done by the electronics. Then looking at electronics, today cameras are shrinking. Okay, so basically they have more components on chip. This is called as a system on chip, SoC technology. So you find that more external components. That means what are the basic components required in the camera? We need amplifiers, we need analog digital converters, we need the timing and control circuits, then video codecs. Codecs are to convert the analog to digital encoding. Then sometimes we use digital signal processing also. Okay, so if you start pushing all these external components, okay, it becomes bigger. So today the technology is so advanced that you'll find the camera has all these external components on one single chip. Okay, they will call it SoC. So that means the PCB size, the printed circuit size, also reduces. It makes them very light, compact. Then power. The camera receives an external power through a DC adapter. All these cameras, be analog or an IP camera, what a camera it is, it requires a power source, and this is powered through a DC adapter, external power. Then enclosure. The enclosure is very important because these cameras can be either mounted inside a building or outside the building. Now, basically these enclosures conform to industry standards. These are called as IP67. IP stands for ingress protection. So 66 and 67, it means for dust and then water and then other parameters which are basically more outdoor environment oriented. That means you are ensured that we put this camera into this enclosure. It's called weatherproof enclosure. You will neither get dust into the camera nor water will get it. So this is called as the IP67 enclosure standards protocol. So this enclosure is very important, and this is how they can go up and get mounted on buildings outside or traffic junctions, etc. So enclosure is important. So this makes up the entire thing. Then coming to the categories of cameras. So basically the camera only category two. Okay, there are only analog cameras. They produce an analog. So let us look at analog type. Even today, analog cameras are still operational and functioning, and I'll tell you where. So analog cameras produce an analog video output and produce a signal of 1 volt peak to peak. It's carried over long RG59 coaxial cable. Basically, these produce analog signals which are typically in the frequency of 1.6 megahertz. That means a high frequency. So we need to have a special cable which is shielded to carry this signal from the camera to a recorder. Okay, and the standards. Basically, we stick to the what you call the broadcast standard. So there are two types of broadcasting standard for television. One is called a PAL or NTSC. So PAL stands for the phase array line, or NTSC, the National Television Standards Committee. So PAL is used in India and in Europe. Okay, we are also following the same standard in Europe and Asia, but NTSC is US based. Okay, so this is all for surveillance applications. Okay, the video is fed to a digital video recorder. So that means we're producing two types of cycle, either PAL or NTSC, and in India, we only look at PAL. So ultimately, I'm getting the video signal from the camera. How do I get it into a recorder? That's important. So we use a device called as a digital video recorder. It's called a DVR. So I'm sure most of you would have heard about DVR. We are all forensics people. You have even worked with it. So the DVR is an embedded box, which takes the analog signal from the camera, encodes it into digital form, and it has got a local hard disk, like your laptop or a computer. You have a hard disk, and you can just put this data, and it converts or encodes the analog into a digital form, and it gets stored. Later on, once it is available in a digital form, you can always retrieve the data and play back. So this is called playback of the recorded video. Okay. And of course, this I have written this sketch with my hand anyway, because I was taking a class for some students. Anyway, I'm just projecting the same slide. You can see what is a DVR setup, analog CCTV. That means basically what is an analog CCTV surveillance construct. It's quite simple. So you have this box called a DVR, and it has got inputs, input 1, input 2, input 3. This all takes analog input. Then I'm shown 3 cameras, cam 1, cam 2, cam 3. They all produce analog output. They are directly connected to the input of the DVR through cables. There will be especially sometimes cables used are RG shielded cables. Then what does the DVR have? To the right-hand side, you can see it has got hard disk. It can have slots to accommodate 2 or 3 hard disks. And the capacity, you can start with a 1 terabyte or 2 terabyte. Normally in DVRs, any recorder, the storage depends on the number of days you want to retain the video recordings and the number of cameras you connect. So that is calculated. Finally, you'll say this is the hard disk I require, and you put it into the DVR. Then it has got a keyboard mode and a mouse port. Then this DVR has an output called HDMI output. You all know what a HDMI output. It is a display port. So this HDMI can be connected to a local display monitor. Then DVR needs a power source. An external DC power output is given to this. Then this DVR has an Ethernet port. You can connect DVR to a local area network. So you can connect this to a LAN switch. And from there, so remotely you can monitor, get into the DVR and view the cameras. So now here I have a system which the DVR is configured. As and when the camera signal keeps coming in, it encodes them and also converts into digital form and stores it. So this is happening because the DVR has an embedded operating system and application software. Okay, the operating system used by DVR is Linux. So it is an embedded Linux system. And there is an application software which is developed for capturing, encoding, and storing on a hard disk. Okay, so this goes on, and DVR keeps recording. But one thing about DVR is not like your other traditional way you create files on your laptop or hard disk. Let us say that you start the day 1. So let us say 30 days recording. So So if you have got 3 cameras or 4 cameras, whatever it is, you have to ensure that all the 30 days recordings for each camera is available. So while the recording is in progress, then once you have calculated the hard disk capacity also for 30 days, and let us say for 3 cameras, exactly after the storage space gets filled up or the number of days, this DVR, it will start overwriting on the day one. So if you have some important data, you have to back it up. So it starts overwriting. So day one data will not be available to you anymore. Okay, you'll have only some remaining 29 days. Then the next day, you'll have day two data will get erased out, and you'll have a recording only of 28 days. So this is how it starts overwriting. So DVR basically technology basically overwrite and the hard disk. And if important data, you have to back it up. So basically, you'll find that DVR has, I didn't show this port, it has got a USB port. Sorry, I did not show it in the diagram. It has a USB port where you can connect a pen drive or a hard disk and take a backup of the recordings. So all DVR supports a USB port, because it's very important that while some incident has happened and you want to take a backup of or take this export the video clip recording, and then you want to give it for investigation. So this is very useful, and this is how you transfer it, okay, from the recording to an external USB drive. And remotely, I can monitor. So if you have got a local monitor connected to the DVR, if a security person is sitting there, he can watch as long as security room. But if you are a very senior administrator and you want to monitor the cameras, since it's connected on a LAN network, so the administrator will be given the login credentials of the DVR. He logs in, he can view all the cameras, he can also play back the recordings. And this is how the DVR technology has been designed. And even to this day, it is still being working and people are accepting it. It's being deployed at many small homes, restaurants, and very small applications. And DVR solutions are very, very cost effective. So, and it's very simple and cost effective to put 2-3 cameras. I'm sure all of you would have had some kind of experience with having CCTV cameras installed at home. Maybe having just 2-3 cameras to watch your house, gate. And 99% everybody goes only with the DVR-based solution because it is works simple, easy, set it up, and very cost effective. Then let's look at the other type of cameras. We call them as the IP cameras. Now we call them IP because it follows the internet protocol. While we were looking at cameras, analog cameras, which went into a box, it got digitally encoded and stored. These IP cameras have everything built into their own chip. That means, as you all know, initially the sensors will produce an analog signal. This analog is encoded to digital form, okay, by using these converters, codecs, we call them codecs. This codec is also built into the IP camera. And second thing is that there is also about video compression. Okay, I will come later in my slides about need for compression, but today, video data produces humongous amount of data. It's a huge thing, video. If you do not do compression, you will end up in bits and bits of huge amount of data which you cannot store it nor transmit it on a network. So there is something called as video compression technologies. So while these IP cameras will have a built-in digital signal processing, and it completely provides a digital output straight away. But as I said, IP, that means Internet Protocol. So this digital output gets packetized. They're converted into Ethernet packets, which follows the TCP/IP protocol. And so you find a video stream. Ultimately, these IP cameras will produce a video stream, which is completely IP protocol based. And if you have a browser, you can capture the video stream through your browser and view the image. Then the DSP, the digital signal processing, will do some simple image enhancement within the camera itself. You can log into the camera, you can adjust the brightness, contrast, you can compensate for backlight compensation, you can improve the dynamic range, because each IP camera has got its own web server. So basically, if you look at what a web server is, it will allow you, it's a tiny web server is basically, a tiny interface, a mini computer, okay, which follows the TCP/IP protocol, which allows you to get into the camera settings. So that means a web server, which means over the net, over the internet, okay, just simply by using a browser, I can log into my camera and view all the settings. I can change the settings also. So this is called as a browser-based settings. And for that, a tiny web browser will be sitting in the camera. That is also part of the IP camera. Then coming to the compression technology. So the digital video is compressed. There are two popular technologies today. Okay, it's called H.264 and H.265. Both are extremely capable, efficient. They compress the data. The reason why we compress so that the bit rates are reduced and it is easy to store it on the hard disk with compression. But then, will the compression give a good image? Most of the time, the compression is actually, sometimes it is a lossy compression, but how much of loss has happened is something not very important to observe. You may notice the loss is very less, and so you can live with it. So you can even do some image enhancement. So today, all recorders, okay, they do what you call a conversion. It is converted into H.264, it means encoded to compressed to H.264 or H.265 built into the recorder. In some cases, it will be built into the camera. Now, this H.264 and H.265 compression technologies in the earlier analog cameras were built in the recorder. As I said, analog cameras don't do anything except produce an analog signal. While here, that means the compression was happening in the DVR. The DVR is the box which does even the video compression. It could be H.264 or H.264. I'll come to the later slide what these are. Then, if you look at the IP camera, you see that all these functionalities are built into one single package, one camera, which is giving you a compressed video stream. That means I have a H.264 or a H.265 video stream, which gets into the recorder. Okay, so it can just go over a network. Since this is an IP-based device, it gets connected to a LAN network, which means I can anywhere on the LAN, I can log into this camera and I can view the image. Okay, then by using just a simple browser. Okay, then it is also possible to get into the camera's web server over the network and carry out all the required settings. Then the IP camera video stream. Now, what do we do with the IP camera video streams? In case of a DVR, so the analog signals are captured and they're recorded in a DVR. So how do we record IP signal, IP data? So the IP camera video streams are captured by a device called a network video record called NVR. So it will be sitting on a same network. So this is an IP-based recorder, which means unlike the DVR, it does not have several input for each camera. Okay, it has only a network port. That means since it's an IP device, I connect to the network and I configure my network video recorder. That means I have assigned an IP address. I have assigned an IP address for the recorder, and I have assigned various IP addresses for the various cameras. They'll all be coming within the common gateway. There's something called a common gateway of your LAN network, and all of them share the same protocols. They're all sitting on the same network, and they have the same gateway. So I will go to the network video recorder settings, configuration. I will select IP camera number 1. This is called IP address 10.2. something. I'll enter. I'll go on adding the IP address to the cameras one after another, and I get it configured. So now what happens? The network video recorder detects the video streams and it starts recording. So it starts storing them. It has also got a hard disk. Just like the DVR, the NVR has a slot, and you can easily put it into your put in the hard disk, and even this hard disk capacity can be calculated depending on number of days you want to retain the video recordings and number of cameras you are connected. These IP cameras again, and coming to the IP cameras, if you say you are able to directly log in, okay, it has a login password, so people just cannot do any tampering with it. Now, let us look at comparison now. Having understood something about analog and IP cameras, what are the comparisons? So, analog versus IP. So, analog cameras transmit video over a coaxial cable. Hence, no bandwidth issue and latency involved. It's a direct video signal coming from one end to another end, and so there's no latency. Okay, there's no delay. The signal lands up without any latency. Then it needs an external recorder like DVR for recording and storage. A DVR requires an DVR. An analog camera without a DVR, you cannot view the camera nor record. Then needs external DC power. So I need a separate power adapter. Then separate cables are required for carrying signal and power. Then there is no local storage available within the camera when it's analog. Then resolution, very important factor. The highest resolution possible is D1, can get 704 by 480 pixels. But eventually now we have moved into something called analog HD. So today, then analog camera resolutions have improved, and the highest that you can get is the full HD. You can go up to 1920 into 1080 pixels. This has been the best resolution available on an analog camera. But it is still analog. It is still not digital. It's an analog signal. Then it does not support for wireless transmission signal. So you cannot make your analog camera Wi-Fi enabled, nor connected to any Wi-Fi network or wireless network. Okay. Then there is no scope for image enhancement within the camera. So let us say that I want to change the brightness, contrast, and few settings. I cannot do it with the camera. It has to be done in the DVR because once analog signal gets into the DVR, it is getting encoded to digital form. So using some simple digital signal processing tech, I can vary the brightness contrast, but this has to be done in the DVR. I cannot do it within the camera. Then it needs to be done at the recorder, right? Then second thing is I think the lens also. Basically, analog cameras lens has got a what do you call as a lens which is not motorized. Okay, that's a sort of fixed kind of lens. It has no facility for getting motorized. But if you look at IP cameras, these IP cameras have lens which are called motorized. That means the lens itself can be remotely controlled. That means I can zoom in, zoom out. If I use a varifocal lens, which is motorized, so I can vary the zoom in, zoom out. I can change my field of view. I don't have to physically even touch the camera. I can do it remotely over the network. Okay, because it is an IP camera. It supports this. And for that, this camera lens also should support a motorized version. So all IP camera supports motorized version of the lens. Then let us look at on the counterpart, let us look at the other type of camera, the IP cameras. IP cameras transmit data over LAN, and hence bandwidth and storage requirements are large, depending on the bitrate settings of the camera, in spite of data compression. So packet latency is common. Like I said, what is packet latency? That means a complete video data. It depends on how your camera settings are there, to which network is connected, and whether all the video packets arrive at the same time at the recorder. Okay, that means finally all the IP camera stream has to come into some recording device. Okay, so does it happen very synchronously or there's a packet latency? There is a packet latency. Sometimes if your network is it has more bandwidth and there's not too much congestion in a network. So it depends on network congestion. If too many devices are connected to your network, then there's going to be what you call bandwidth congestion. So you find your router will not send all the packets at one time, depending on the traffic. It starts sending packets at one time, and finally, all the video packets, will arrive at some point of time. This is something which you might have noticed in your mobile phones while streaming video. It says buffering. Okay, this is what is called buffering. It goes on buffering and buffering because of the bandwidth congestion. Okay, finally, till the bandwidth gets clear. So this is one drawback of these IP cameras. So you will find a latency. Packet latency is very common. Then power. IP cameras gets power over a single Cat6 cable. It's called power over Ethernet. That means I do not have to provide another separate cable for the power. That means there's one single network cable called Cat6 cable. It carries power and also the data. It's called power over Ethernet. So both data and power carried on a single Cat6 cable. Then local storage. Since it's an IP camera, this has got an SD card slot. All IP cameras have an SD card slot where you can push an SD card, like your mobile phones. It can start, even up to something like 32 GB. It can go up to 256 GB on a micro SD card, which means on an IP camera, I can do recording even without an NVR. Okay, so let us say that I want to put up a quick, for example, a surveillance. Let us say there's a situation where you want to set up a camera very quickly, and I don't want very expensive hardware and connections and cables, etc. I want a local recording to be happening within the camera. So what I do is that I will enable the SD card recordings. So I can put up 256 GB even for 7 days, 24/7, 7 days, it can easily hold your data. So that means I don't need an external record like an NVR. So that's a great advantage that has got a local recording. It's called recording on the edge or recording within the camera. It supports that. This is not supported in analog. So, and since it's an IP camera, the support for wireless transmission like Wi-Fi. So I can simply make this camera, when many a times, I have seen people, even the police, sometimes they want some incident to be captured quickly. They just make this Wi-Fi enabled as long as the Wi-Fi hotspots. So if you are having a Wi-Fi hotspot and you are within the Wi-Fi range, then you just make your camera Wi-Fi enabled. There are cameras which are directly Wi-Fi is built into the camera, or you can use external devices which makes a camera, an IP camera, Wi-Fi enabled. So you have to assign an IP address for it, and the transmission goes on. Up to 300 Mbps, you can transfer video. Then also let us look at situations where you have point-to-point, long-distance data communication video. Let us say particularly seashore. We have seen in some of my experience these police, what we have done in some places is this Mangalore beach coast. So where you have to put surveillance camera along the coastal line. It becomes very difficult to run even optical fiber cables up to 10 kilometers, long distances. So there is something called as the point-to-point radios. It is something called as the MIMO, multiple input, multiple output. These are called the communication radio links. So I'll put the camera very close to the seashore where I want monitoring. And of course, power. I can make it on a solar powered or a built-in battery. I have some power mechanism where I don't have any cables there, and it can be solar. Then this camera is connected to this radio. So that means I can go up to 300 megabits per second. I can transmit a video, and from the camera, it gets into the recorder we call central monitoring. So I have another building, and I'm assuming that we have a good line of sight. The most important thing, line of sight. There should not be any obstacle buildings in between. And so I have a clear line of sight of 10 kilometers, and this video signal picked up from the camera will land up into the record. So I start recording. So this is a great advantage of IP cameras. Okay, so this is great, and this is being, even deployed even now in many coastal area applications. Then there is something called on-the-edge image enhancement. Now, since it's an IP camera and there is a DSP and all built into the camera itself, I can do some operations on the image, like improving the wide dynamic range, compensate for backlight, then digital noise reduction. All that is possible with the IP camera. Then IP cameras can stream to recorders such as network video recorders. It can go to also video recording servers. So many times what happens, if you look at a network video recorders, they have a local storage we call it as a direct attached storage called DAS. Okay, many times if the capacity goes beyond this, you want, let us say you have only terabytes, but you want petabytes of data to be stored, then you can't do it with the NVR kind of technology. So we have to use an extended, what we call recording devices. We call them as the NAS, network attached storage. You can go up to 1 petabyte. And then the video recording servers, many times if you want to scale up, if you look at NVR, you can have maximum number of cameras that can connect to NVR. Today is 64. Okay, even 128 is not available, but it's still as of now 64 IP cameras you can connect to one single network video recorder. But eventually, there's no scalability. If you want to scale up your video surveillance system and add more cameras, then you have to add multiple network video recorders. That means you're duplicating more and more hardware. So which is really not a wise thing to do. Rather than that, I will have a simple video recording server where I can configure up to 255 cameras. Okay, and this servers itself will have some local storage and also can have extended storage like NAS. So you find that easy to add cameras to network. It's a plug and play, providing good scalability. That's a great advantage of IP camera. You can easily plug in a camera to the network, configure an IP address to it, and your recorder starts receiving it and records. Then there's a motorized lens. Like I said, all IP cameras have a motorized lens for zoom and focus, which means you don't have to climb up a pole. For example, these cameras are mounted outside in traffic junctions. So one need not climb a pole and do some adjustment to the camera for lens. It's remotely done over the network. So that's a great advantage. Then as compared to analog cameras consume very less power, okay, typically 2 to 4 watts. But here, IP cameras consume more power because they have a motorized lens, so 8 to 10 watts with motorized lens. So here again, I am showing you a diagram, a sketch of how an IP camera-based CCTV surveillance looks like. So here you can see this network video recorder. Like DVR, this is also an embedded Linux system. The operating system Linux, it's an embedded box, and you can see partitions of hard disk, HD1, HD2. You can populate the way you like it, whatever it supports. Then it provides an HDMI port output, which you can connect to a local display monitor. You have a keyboard and a mouse. This NVR also has a USB port. I used out in my diagram. So you can connect an USB drive. You can take a backup of recordings. Here you find, look at the way the cameras are connected here. Unlike the DVR, the cameras are directly connected to the DVR. Here it's not so. All the cameras are connected to a switch first. It's called the power over Ethernet switch, POE switch. This POE switch also has another port called uplink port. So if I say that 4 cameras were connected, I go for 8 port POE switch. So out of the 8 port, all 8 ports can be used to power up the camera and take the data, while one port is called uplink. This uplink port gets connected to your local LAN network, your local LAN network switch. So by doing this, then NVR. So you can see a small pencil-like sketch which I've drawn. The NVR gets connected to the LAN switch. So now NVR, all cameras, POE switch, all are sitting on the same gateway network. So now I go to the NVR, I keep adding the IP addresses for all the cameras, and it starts receiving the streams and starts recording. Then I have a remote laptop. I can get myself connected on to the NVR, login, and through the login credentials, what has been provided, I can now log into the NVR, see all my IP cameras. I can even play back the recordings. I can see everything. Okay, this is a typical setup of what you call IP camera-based surveillance. And you can see that there's no external power for the IP camera because it gets everything over one single cable. So this is the architecture diagram for a typical IP camera-based surveillance, and this is what is being deployed for large campus surveillance. Your TRASAP, what do you call that? City traffic junction, law and order, your own campus at NFSU. I'm sure you have a lot of cameras. It will be connected this way. Then let us look at the various types of surveillance cameras today. Basically, you have bullet cameras, the dome, PTZ, body worn cameras, panoramic view cameras, drone, and Wi-Fi. I'll just brief you through each of this and quick. Basically, we look at the bullet camera. It looks like a bullet, and then the technology uses a CMOS sensor. It is suitable for outdoor applications. It comes with weatherproof and vandal-proof enclosures. It supports both fixed and varifocal lens, which are motorized. Then it has got a built-in IR illuminator. So basically, all this basically we call this as the night vision. If you look at all the cameras, they are sensitive to both day and night. But what happened during the night? So in the night, during the night, you don't have enough illumination. So today, all cameras, even be it analog or an IP, you have built-in infrared. Okay, I will come to that in the later slides, why infrared is required. So basically, it has an IR illuminator, which sends out an IR, throws an IR beam in the area, and it captures the light. But when you get an IR illuminated image, it will not be color because IR works in a very narrow spectral band, the optical band. So it will be from 750 to 1200 nanometers. So it will not produce all the colors. So basically, an IR image will be just a black and white. I'll show you that also later. Then this camera has got a built-in SD card for local storage, and it has power or Ethernet, only single cable for power and for data. Then resolution supported. That's a great thing about IP camera. You can start from 2 megapixel, you can go up to 8 megapixel. Today, up to 8 megapixel surveillance cameras are available, and that is possible on the IP cameras. Then frame rate up to 25 frames per second. Then compression. I said video compression supports are both H.264 and H.265. H.265, the video compression will be required when you are using high resolution cameras, while H.264 will be good for a 2 megapixel camera. Okay, so this compression technology also depends on the resolution camera that you want to use. So today, all camera manufacturers have provided both the compression because people are now going. Today, the resolution that is required minimum is a 4 megapixel. If you want a good clarity image for your forensics investigation, okay, you are not even leaving even 2 megapixels not be sufficient. Okay, reasonably 4 megapixels is good enough, but 8 megapixel will be higher in it also, but special cases. But I'm using a 4 megapixel pixel resolution. It's a high resolution, but then it so happens the bit rate also is very high. So the compression H.264 will not be so effective that I use what you call H.265. Yeah, this is the way it works. Then there is a standard called ONWIF. It's very important in all IP cameras. It stands for Open Network Video Interchange Format. That means, what does it mean? It means when I have a camera, okay, from any manufacturer, if it's an IP camera, it should say it is ONWIF compliant, which means it should work with any recorders, any NVR, any video recording server, and any video management software which supports ONWIF compliant. So that means I can have any manufacturer. Okay, there are more than 100 OEM manufacturers for surveillance cameras today. So anybody who says that this camera is ONWIF compliant, you can simply buy it. That means you have to ensure that this feature is supported. Then it works with all popular browsers. Okay, all these cameras, any browser, you can just use it and log in and get the camera settings of you. Then various network protocols are supported. Then supports 3 video streams. Always IP cameras will produce minimum of 3 video streams. Each stream has got its own profile settings. I can set the resolution, I can set the frame rate, I can set the bit rate, etc. Why this is done? Because bandwidth is a major problem. So if I say, let us say stream 1, we call it the mainstream. The mainstream will be configured to give the highest resolution, highest frame rate, because it goes for recording. So I'm going to use the mainstream only for recording purpose. Okay, so that recording is not affected or compromised. So during investigation, when I play back, I still retain all the resolution. The second stream is only for viewing. Okay, that means this can work with a lower bit rate and I can reduce the resolution. This is meant to be monitored remotely on a video wall or a central monitoring station where operators can just view the video. I don't require such a high bit rate and resolution. So the third also is used, but if you want, three streams are available. Generally, we use only two streams. So all this bullet IP camera produces multiple streams, minimum three. Then it can work in unicast or multicast. That means I can see that the video stream is received only for unicast mode, or several people can receive the same video stream. It's called multicast mode. And this is how a bullet camera looks like. I'm sure all of you have seen this in your own campus. Then coming to the dome camera also has the same technology. Everything is the same, except that even here the resolutions go from 2 megapixel to 6 megapixel. It has got a built-in SD card. And all these, like I said, there's a built-in SD card. You can store the data locally without connecting to a network or a recorder. Then it is on with compliant. Then it works to all standard browsers. Rest of the features are all same, a dome camera, and this is meant for indoor application. And you can see surrounding the camera, you can see these LEDs. These are called the IR LEDs. These will work in the night only. Okay, when the light automatically goes down below a certain lux level, it comes on and throws it on the area where it has been illuminated. It picks up the reflected image. So this is a dome camera. Then you have pan, tilt, and zoom. This is very, very important. And sure, this pan, tilt, zoom is a camera which can rotate 360 degrees, mainly for outdoor application. It has got a good weatherproof enclosure, and it has got a fantastic optical zoom of 32x. So you can see the focal length. It can go from 4.5 mm to 135 mm. Okay, which means that if you have a vehicle standing at 1,000 meters from the camera, I can zoom in because I've got 32x optical zoom. I capture the number plate. A person is standing there. I can capture him at very close range. I can see who the person is. I can recognize this feature. This is because optical zoom up to 1,000 meters, up to 1 kilometer. Of course, there should be a clear line of sight. Then it can go in a 360 degrees with presets, which means auto preset or auto patrolling mode. Many times, all PTZ cameras are manually rotated by it's a move. That means from the control room, you see today an example is all the traffic junctions. Today, if you look at all the traffic junctions, there's a PTZ camera and your traffic monitoring center, the operator will be seeing who the traffic violations are. So when they see that the vehicles are parked on the zebra crossing, which is a violation, they immediately zoom in and capture the number plate and you get a fine notice. So these are used essentially for this traffic management applications. And in another case, it has got also for auto patrolling mode. This is basically for border area security. So during the night, our defense forces are using this, that entire perimeter will be automatically in patrolling mode. That means it just patrol movement, it goes in every step, every 1 degree or 2 degrees. It slowly moves around patrols. It covers entirely one rotation of 360 and produces a video. So in that, you can see if there any movement of intruders and enemies is easy. So very good for auto patrolling. Then it has got a built-in IR illuminator. This IR illuminator PTZ can throw up to 300 meters. That means you can throw infrared from this camera up to 300 meters, means close to around 900 feet. That is the power of the IR. It's greater IR power is here because you can illuminate a vast area because this is extensively used in the defense. During the night, there will be no light, so they can use it. Then it has got a built-in SD card for storage. Then it has these will generally don't work on PoE because it consumes more power because it's a motor. Since the motor is involved, a PoE port may get loaded. Some extended, some higher PoE versions are available, which can give more power. Otherwise, generally they use an external AC power adapter. The resolution supported earlier 2 megapixel to 4 megapixel. Today, even up to 8 megapixels are available in PTZ. Then frame rate up to 25 frames per second. And here also compression technology is H.264 and H.2. Both are supported. Then on with complaint, it works with all other browsers and same, all other things are same. And this is how PTZ camera looks like. I'm sure all of you have seen this. Okay. And this is the rotating part. The black thing keeps rotating. And there's only one sensor which keeps moving 360 degrees. And that's how it's mounted. Then we have the body worn camera. This has come very recently and deployed by the law enforcement agencies. Basically, it is a camera which is clamped onto the policeman's body on the shoulder. And here it's again a CMOS sensor technology. It uses H.265, H.265. But here the camera is very tiny. It will be something like a mobile phone camera. So that means it's a very tiny sensor, and it has got a fixed focal length, not vary, because It has got a fixed focal length, typically 3.8. It covers about 72 degrees. And the resolution, you don't get much higher than 720p, 1280 by 720 pixels. It stores the data only in internal SD card. So it has got internal SD card. So when the policeman is talking to somebody, a violator, whatever the policeman is seeing, for example, an accident would have happened, then this body-worn camera captures the video, immediately starts recording. Okay, or the entire accident scene, and it uses a lithium-ion battery, and it can support Wi-Fi and Bluetooth and GPS. All these communication protocols are supported on body-worn camera. Suppose if you are within a Wi-Fi hotspot zone, so it's possible that this can be connected to a Wi-Fi network. Through the Wi-Fi, the control room can see this. Okay, then it has also audio. See, this sometimes will record the conversations which happens between a public and a policeman. So it has records audio also. Then it has got a weather-proof rugged because it will be hanging on outside on the shoulder. It will be the heat, dust, and rain. It is protected. And it comes in a very compact size, which can be clipped onto the body. So this is how your body-worn camera looks like. And this has been now popular all over the country, and traffic police are carrying this most of the time. Then the panoramic view camera. So many times what happens, the 360-degree field of view, if I go for a PTZ camera, I have to keep rotating the camera in auto mode, or I have to manually move it. So there's a need. This kind of panoramic camera IP camera produces a 360-degree field of view, having some multiple sensors within one single camera housing. And the resolution can go up to 12 megapixel. So these are generally mounted on the ceiling. If you go to some, what you call a department store, if you go to shopping malls, airports, so it's basically uses a fisheye lens. I'm sure you know what a fisheye lens. The fisheye goes up to 180 degrees. That means it's got a more coverage of view than a human being. It's called a fisheye. The lens used is called a fisheye or a panomorphic lens. Again, there's a special lenses used in this, and it can be a good replacement for PDZ camera in some applications. So I don't have to manually operate camera. I get a 360-degree view of the entire ground floor if I put it on the building. So this is very convenient. Then the videos that are produced from each sensor are stitched together by software, and you can get a continuous, video. Of the entire scene. Then it has got a weatherproof enclosure. It can work in both indoor and outdoor environments. It has got a power over Ethernet because it's an IP camera. Then some dewarping is supported. So because there's a warping happens because of the fisheye effect, so the dewarping will be done during the software. So for the optical distortion, it's compensated. And this is how it looks like. So you can find some multiple sensors, and each sensor can cover up to 90 degrees. So you may have 4 sensors, and each gets a field of view and puts it together as 360. This will be normally mounted on the ceiling, okay, in a place where you get a complete 360 degree of the entire surrounding. Airports are using it, shopping malls are using it, and some big places where they want it. You can see this also in many places. Then the drone cameras, and today drone has become very popular for aerial survey, capturing video footage for both agriculture and monitoring of traffic. So these drone cameras are special cameras which have resolution of 4K, okay, and it uses H.265 compression at 60 frames per second. Since the drone keeps moving, so we need the camera also to operate at a higher frame rate. So these drone cameras are designed for 60 frames per second and maximum speed 50 kilometers per hour, the movement of the drone. Then micro SD card. So there are 2 ways of doing this. Most of the drone cameras have what they call Wi-Fi. It's called extended Wi-Fi. So you can see the drone operators, they carry a remote with them. So when they fly the drone, so the camera will start streaming out the data through Wi-Fi. You may go out of, this is not a traditional Wi-Fi, it's called extended Wi-Fi. A Wi-Fi itself can cover up to something like 100, 200 meters. This extended Wi-Fi can go much more. So on the camera, it uses extended Wi-Fi, and your remote unit, which you are holding in hand, has a small LCD display. You can see the image, right? And this communication happens by Wi-Fi. Apart from that, there is a micro SD card sitting inside the drone camera, which records everything it sees. And the flight time, normally drones do not run for more than 30 minutes, okay, because there's a problem with the battery draining out. And the lens, it depends on the area of coverage, and suitable lenses are used. And it's powered by lithium-ion battery. This is how the drone cameras looks like. And today, I'm sure most of you have seen it for either entertainment or weddings or people doing it for agriculture survey or inspection. They're being used in factories for doing, in steel plants, use it for inspecting their solar panels and chimneys, etc., whatever it is. Then the Wi-Fi camera. So Wi-Fi camera, like I said, again the camera is technology is all same. It's a lens, a fixed type. Resolution is basically, and here it requires an external DC power is required. Okay, or this Wi-Fi camera can also work on PoE. That's also possible. Then it supports a micro SD card for local recording. Then it is on-with compliant. Then wireless connectivity, it follows the IEEE standard 802.11b/GN, which is at 2.4 gigahertz. This is the frequency spectrum. And you can make this camera totally Wi-Fi. And you can make this Wi-Fi camera completely cableless. Okay, the entire thing can be powered by lithium-ion battery, and this is extensively used when they want to set up a very quick surveillance system, and they don't want any cameras. I think you can see that even the spy cameras. Sometimes they use the spy cameras. These spy cameras, okay, they are Wi-Fi enabled, very tiny, and used for spying on people, whatever it is, and it transmits the data Wi-Fi to your mobile phone. So if I have an app running in a mobile phone, because my mobile phone is also Wi-Fi enabled, so I capture this from the spy camera. I can see it in live, or it can also be recorded locally within it has a micro SD card to be recorded. Okay. And this is how the Wi-Fi camera looks like. It has a small antenna, and a antenna which radiates the Wi-Fi signal. Okay. Then most important thing is I have discussed what is this video compression need for video compression. So there's a small calculation I'm showing to you. Let us look at a typical camera for IP camera. So the bitrate calculation for IP cameras. Let us take a camera resolution of 2 megapixels, which means what is the frame size or the image size is 1920 by 1080 pixels. And what is the depth of each color? Red, green, blue. It is 24 bits. It's encoded 24 bits. 24 into 24 into 24. You can just imagine. So total number of bits per frame will be 1920 into 1080. That is the frame size. Into 24 to the power of 3. That means 24 into 24 and 25. You can see a huge number appearing. So many bits per frame. So one frame will consist of so many bits. And we are now refreshing at 25 frames per second. So frame rate becomes 25 frames per second. You can see this now total number of bits streaming per second. Okay, the huge astronomical number that you see here. This is the raw data without compression for just one camera alone. For one camera alone, this is the bit rate required. So no video surveillance system, no bandwidth can handle this. Okay. So the above bit rates is so high that physically no network can handle this bandwidth. And there's a great need for video compression. So the innovators, people start developing the video compression technologies. They are called as coding decoders. Initially they came with H.264, and second they came to H.265. So with H.265 codecs, the above numbers drastically reduced to 5 to 6 megabits for one single camera. If I use a H.265 codecs, they're deployed for a 4K resolution camera, which yield typical rates of 6 to 6.5 megabits. So I brought down the bit rate to only 6 to 6.4 megabits for a 4K resolution camera. Okay, and with the H.264, it can still be much lesser. For that, I use a 2 megapixel camera. So without the above video compression technologies, no IP-based surveillance system would have become possible in this world. So there have been no video surveillance today had it not been for the video compression technologies, and thanks to the innovators. Then what is the need for infrared? So like I said, low light. So during the night, okay, when you get into very low light, the camera will still try to produce a color image with noise. Okay, so what happens? We have found in the recent, many times, you might have seen many of the recordings that you would have seen produced by cameras, which you forensic people would have demanded of an incident. Okay, this could have happened during the night, and you say that even though it has produced a color, that it is very noisy image. You can't make out the person's face, you can't make out the color of the vehicle, etc. Right? So basically what is happening, the second drawback is that as noise increases in the night, it increases the bandwidth and storage space. Both are disadvantaged. So what is the point in me spending more on bandwidth and storage, and yet I don't get a good quality image which is noisy? So they decided we will do away with this and go for IR based. So what happens when the light falls below a certain threshold, the sensor inside will turn on the IR. This IR will give you a black and white image. Since it's a black and white, noise is reduced, bandwidth is reduced, and you can see only a white and image. This IR works in the spectrum of 850 to 940 nanometers. Sometimes it's also called near IR band, near infrared. And this IR illuminator throw distance can vary. That means the throw distance of an IR illuminator can vary from 30 feet to 300 feet, depending on the type of camera. And hence, with IR camera, you can still produce a black and white image with even at 0 lux. So this is what I'm showing. So you can see here, this is a pitch dark. Okay. And of course, the picture is not not of great clarity, but you can see that you can make out there are some dogs and two people standing there, and the trees are there. This is all. Maybe it's not a sharp focus image, but this is the power of IR and advantage of IR. Then coming to something now about recorders and storage. Okay, so basically, the DVR was one of the most popular recorder, which is an embedded PC containing a Linux operating system and is extensively tied up and associated with only analog cameras. Okay, you can connect up to 32 analog cameras in one DVR. Now, I think maybe now it is increased to even 60, 32 and then much beyond. But gradually, eventually I have not seen nothing much more than 32. And analog signals from camera are entering the device. So it gets converted into digital form and also gets compressed. Usually H.265 codecs are being used. Then this compressed data is stored on the internal hard disk, whose capacity can vary from 1 terabyte to a maximum of 32 terabyte, depending on the number of cameras and video retention duration. This is basically a DVR kind of a storage. Then look at the DVR also has an Ethernet port, which can be connected to a network. Then DVR provides both HDMI and VGA output. You can connect to a HDMI display monitor or a VGA monitor. So you can view the recordings live, or the live cameras can be monitored. So DVR normally supports the following functions: viewing all the live cameras, then recordings and playback, then playback of the selected camera recordings according to a particular date and intro time. You can export it to on a USB drive. So you can take a backup of it when you want it for post-investigation. So this is how a DVR looks like. So the front, the back, if you see the rear side below, the below is the bottom, rear side of the unit, you find many connectors called the BNC connectors. These are all so many analog cameras. So you can connect so many analog cameras to this. So each analog camera is connected on the special connector called a BNC. Okay, so these are called BNC connectors, and you can connect up to 16 here. Then it has got, okay, you can see it has an HDMI port, it has got a VGA port, then it has got an Ethernet port, which you can connect to a local area network. It has got a power source, can be external DC power source. So this is how the rear side of the unit looks like. The front side has got only a navigation button. That means this is something like a very old video cassette recorders where you fast forward and play back, exactly like that. I can go forward, I can go backward, I can search for the recordings. Then I can also stop the recording, pause, I can do all that. Or I can go frame by frame, I can do all that with the DVR. This is the technology even today being used. It is still not obsolete, it is not getting phased out. Then if you look at the NVR, as I said, there's no need to again encode the data. It's already an encoded, it's already a compressed data which is coming from IP cameras. So its job is only to receive all the IP camera streams recorded. Like DVR, you can go to the date and time calendar, select which date and which time you want the video recording to play it back. You can play and see it. Okay, and you can here also the hard disk. You can go up to 96 terabytes. Some NVRs are slightly bigger. You can accommodate more slots. You can have up to 96 terabytes. Then it allows to export selected playback recordings to external drive. It has got a VGA and HDMI output, which can connect to any display monitor that you like. Then it supports all resolutions of cameras starting from 1.3 megapixel to 8 megapixel. Starting from the lowest resolution of camera, it can accommodate up to the highest resolution of 8 megapixels. Then some minimum features such as selecting the region of interest. The NVR itself provides some minimum software. You can select the region of interest, and then you can draw a line called the line crossing. You can introduce a line crossing line. So intrusion detection. So you can carry out an intrusion detection, a very simple analytics, where it can raise an alarm when some intrusion, when somebody crosses that line. This is built into the NVR itself, and this feature is supported. Okay. Then NVR allows viewing of all the live camera feeds on a display monitor. So this is how the NVR. So you can see the rear side of the NVR back side. It has nothing but except it has one HDMI port, it has one LAN port, and it's got a USB port. You can plug in a USB device and take a backup, right? And the front, of course, we have only a navigation button, and you can go fast forward, backward, etc. Then continuing storage. Suppose let us say video demand. So as you all know, video demands humongous storage. So we need more and more space because retention time sometimes are 180 days, not 30 days. And people are talking about cameras up to 500 cameras. So where is the extra storage coming from? The big challenge. So no longer the dash means direct attached storage. This storage built into the recorders will not work anymore. So we need what you call extended storage, extra. So we have go for NAS. So NAS is network attached storage. It's something like a shoebox. So I can populate a NAS with a few terabytes. I can go up to petabytes. So I can put several NAS on the network. So I can go on multiplying my storage capacity. And this NAS is sitting on a network. Since sitting on a network, I can push my camera data or from the video recording server, it can address and push the data into the NAS. Okay. But only thing is that here, everything has to be on a network. So if I want to record, recording is all configured, but if I want to play back and get the recordings, I should log into a particular storage device and play back the recordings. So today we are looking at even petabytes of disk space, okay, available on a NAS. So this is called scalability. So when you want scalability in terms of storage, NAS is the best solution, or sometimes people use even SAN, storage area network. But NAS seems to be quite affordable and used. And power. Power is very crucial. We have to keep all surveillance systems working for 365 days, 24/7. So power generally is drawn from what do you call it, diesel generators or UPS. Okay, it's mandatory and there's a backup. Then we have the central monitoring station, very important, called CMS. Ultimately, what is happening to all the camera feeds? They have to be monitored by somebody. So we create what you call a control room. Okay, it's a command and control center where we call it as the central monitoring station. All the camera feeds are landing up here. They're all connected to desktop workstations. So there are many operators here. So if you're talking about 200, 300 cameras, all the camera feeds are brought in here. And then this center is responsible for monitoring all the cameras on your campus. Okay, simultaneously. They can also access recordings, playback, everything is possible. And sometimes they use what you call video walls. And today video walls are also being deployed where you can have very huge video walls where all the cameras can be displayed. Okay. So this is all meant for a 24/7, 365 operation. This is called as the command control center or a central monitoring station. Then coming to the software, we have video management software, video analytics, and video footage auditing. So let me look at VMS in brief. Video management software is also called the operating system of a computer. So if you look at your servers and you look at your desktop machine, there is something called operating system. What does the operating system do in a computer? It manages all the resources within the unit. Okay. And so it's able to tell you how to access the memory, how to access the hard disk, where to store the file, basically an operating system. But here, the VMS is responsible for monitoring all the network devices. The cameras are IP cameras. So it monitors all the cameras and all storage is on the network. It monitors all the storage components. Then it monitors the bandwidth. That means how the bandwidth is being utilized, whether there's congestion and things like that. Then also it shows you what you call the health of all cameras. It is quite, and network, how the network is getting connected. There'll be all peer-to-peer network, several network nodes would have been created, and some network would have gone faulty, it would be down. Then it immediately pops up and shows this particular network node is faulty. That means it's a one screen, there's a dashboard, and the VMS shows everything. Okay, it's a great, and it allows you to monitor the health of all cameras, recorders, and other devices on the network. Okay, and it even tells you which camera is down, or if the cameras are dropping packets. It's quite possible that the camera is not streaming properly and packet loss is there. That means the packets are getting lost. Okay, so if packets are lost means it is a loss of data. So even that it monitors. So this VMS is very crucial for a very large CCTV system, not for a small thing. If you're looking at enterprise video surveillance, so today something called enterprise video surveillance. We are talking about cameras up to 400, 500, huge factories, huge buildings, huge power plants, where large number of cameras are deployed. VMS is a must. Okay. And it has got a customized user management. You can create password, login, allows administrator login, and they can create log reports. And you can organize your display also. You want to view 4x4, 8x view, how you want to view all the camera feeds. All that management can be done. Then support for third-party products. That means it could be a mix of analog and IP cameras at different brands, make, etc. And VMS ensures that all these devices are compatible and operate smoothly. Then bandwidth management. So it also manages bandwidth. So it will find out which is consuming more bandwidth. So it will do some optimization, see that there's no congestion. on a network
So,
traffic.
Shankar sir,
Yeah.
excuse me, sorry for interrupting, sir. Actually, we are running out of time, and
Granted, I have
next
to
speaker is
last
waiting.
another 5 minutes. Okay.
Yeah, no problem, sir.
Fine. So the video analytics class is basically we look at face detection, automatic number plate recognition, video synopsis, and video forensics. Okay. Anyway, these are essential for doing some analytics on the video. Anyway, I don't want to take much time. And of course, video footage auditing to be done as SOP to deter crime, and the software tools available. And challenges ahead. So cameras are increasing in large numbers globally, and challenge for storing the data is important, and intelligent algorithms. So operators cannot be sitting in front of the screen and watching all the time for incidents. So we need automatic, what we call incident detection algorithms, which are AI and ML based. Okay. Thank you very much. Any questions?